On August 5th, 2026, Meta released Muse Code, a terminal coding agent, and Muse Spark 1.2, the model built to run it. Meta's developer blog makes a specific claim. The model was trained across multiple harnesses, so while it is at its best inside Muse Code, it still generalizes to other coding agents you already use. That is a testable claim. So we tested it without installing Muse Code at all. For the task, we used Meta's own cookbook sample, Bastion Breaker, at commit 9FAA831. It is a small game with a pure simulation core, and it ships with one deliberately planted bug plus a 3-test oracle. The world rule is simple. The player's shot breaks exactly one brick, and the enemy's shot must never break the bastion the enemies hide behind. Running Meta's oracle on the unmodified sample gives 1 failed, 2 passed. Enemy fire destroyed 1 brick, and it must destroy none. That is our starting line, and it is machine checkable. But there is a problem with using this sample as a test. The shipped code labels its own bug in a comment that says, quote, "bug planted." The enemy laser destroys the brick too. The answer is written directly above the broken line, so we ran every model twice, once on Meta's file exactly as shipped, and once with only those 3 comment lines deleted. The executable code in both versions is byte for byte identical. Both start from the same 1 failed, 2 passed. Each model received 1 fixed brief, the failing engine file, and the read-only oracle through a plain OpenRouter chat completions call at temperature 0. No Muse code, no agent loop, no tool calls. Return the corrected file, changed nothing else. Then Meta's oracle graded the result, and we byte-compared the tests afterward to confirm no model had quietly weakened them. All 6 runs passed. Muse Spark 1.2 fixed it in both conditions, and in the harder no-hint condition, it was both the fastest and the cheapest run, at 5.88 seconds and about 1.2 cents. On this task, the generalization claim holds. That could have been the end of it. 6 green runs, claim verified. But the oracle only asserts that enemy fire destroys no bricks. It never says what should happen when an enemy shot actually reaches the wall. 2 completely different games satisfy that assertion. The shot can be stopped by the bastion, or it can pass straight through. So we replayed 1 isolated enemy shot against all 6 patches that had already passed. 4 of them let the shot through. 2 of them stopped it dead. 6 green runs, 2 different games. Here are 2 of those patches running the identical scenario, side by side. Same model, same brief, same oracle. The only difference between them is those 4 deleted comment lines, which have no executable meaning at all. On the left, the shot dies at the bastion. On the right, it passes through and continues toward the player. Neither wall loses a brick, so neither patch violates the test. Both panels report 3 passed the entire time. Muse Spark 1.2 produced both behaviours, and the test summary never changed. So which behaviour is right? The module docstring answers it. The enemy's shot must pass over the wall and can hit the player. Passing through is the documented intent. Yet, in the as-shipped condition, 2 of the 3 models produced the other behaviour, and Meta's oracle reported success for both. The specification existed. It was written in English, 3 lines above the code. It simply was not encoded in any assertion. Now, the limits, because they matter. This is 1 task, 1 prompt, 1 attempt per cell, 6 runs total. It is not a general coding benchmark, and it is not a review of Muse code, which we never installed or ran. Costs are OpenRouter reported figures for these specific calls. The probe covers 1 unspecified behaviour, not an exhaustive audit. A single run is never a model verdict. The useful finding here is not a ranking. Meta's claim held up. The model fixed its own vendor's planted bug through a bare API call, quickly and cheaply. The finding is that passing the provided test did not mean the patches agreed with each other. When an agent hands back a green test run, that tells you the assertions are satisfied. It does not tell you the behavior outside those assertions matches what you intended. Everything here is reproducible. The scripts, the raw model responses, every patched project, and the probe output are all published.